Hello everyone. In this lecture, we can learn about transmission control protocol. So, transmission control protocol is considered as one of the important protocol belong to the transport layer. So, when we learned about the OSI model, there we found that the transport layer plays a main role in taking the data, that is the entire data, from the sender to the receiver. So, there the transmission control protocol is playing a main role. So, to know about this protocol, the simple concept is it is a connection oriented protocol, and also it is a reliable protocol. It is a connection oriented and reliable protocol. So, TCP defines the connection establishment, data transfer, and connection termination. So, when we practically involved in data transfer with TCP, and when we observe the TCP connection, there three phases are available. One is connection establishment, and one is data transfer, and next one is connection termination, or we can say connection teardown. And TCP uses a combination of go back and protocol and also selective repeat protocol to provide much reliability. And now to say about the TCP services, because TCP normally work in collaboration with IP, that is Internet Protocol, and with the work of the TCP IP, we can say that the data will be delivered to the correct destinations wherever they are through the network. And TCP services, we have one point is process to process communication. So when transport protocol is functioning, in one side client and other side a server, in individual places behind everything, the process to process communication will be there using the port numbers. Second one is the stream delivery service. So TCP is a stream oriented protocol. So bunch of data we can send because it is a connection oriented protocol. So TCP allows the sending process to deliver the data as a stream of bytes, and allows the receiving process to obtain the data as a stream of bytes. Therefore we can say it is a stream delivery service. Then at the transport layer, the TCP groups a number of bytes together into a packet called a segment. So this segment is called as TCP segment. So TCP adds a header to its segment and delivers the segment to the network layer for transmission. And the segments are encapsulated in the IP datagram and will be transmitted. So this format we can say that is TCP segment or TCP datagram. And for the connection oriented service, we say that when a process at site A wants to send data to another site, that is B, there three phases of functionality will be engaged. One is that two TCP establish a logical connection between them, and the data are exchanged in both directions. And finally, the connection will be terminated. That is, once the communication is over, then the connection will be terminated. Now, certain features of the TCP, that is TCP is a reliable protocol, that is the receiver always sends the either positive or the negative acknowledgement about the data packet which have been sent to the receiver, and the TCP ensures that the data reaches intended destination in the same order as it was sent. Also, the TCP is a connection oriented protocol. Therefore, we can say that the TCP will be requiring the connection between the two remote points that will be established before sending the actual data. That means before data transfer takes place, we need to concentrate on connection establishment. So that process is more important. By forwarding sync bit and by getting the sync plus acknowledgement information from the receiver, any node as a source can able to create a link with another node B or another node receiver to carry on with the data process. and the TCP provide error checking and recovery, and it is a normal end-to-end communication, and it provides flow control, and overall it will maintain the quality, and the length of the TCP header will be minimum 20 bytes long and maximum maybe 60 bytes, and TCP support for label service. So here we can able to see the TCP header, that is a TCP segment, and which contain the source port address and the destination port address. Each of it is 16 bits. Then sequence number, acknowledgement numbers. Then you can see the header length of 4 bits. Then 6 flag bits will be available, and these flag bits are taking some importance in telling about or in observing the performance of the TCP functions. Here the urgent bits, that is urgent pointer, is valid if it is set to 1. Then what you have is ACK, that is the acknowledgement bit is set to 1 to indicate that the acknowledgement number is valid. Then you have the push bit PSH. The receiver should pass this data to the application as soon as possible. And then reset. This flag is used to reset the connection. Then sync bit, that is in order to get synchronized with the sequence number to initiate the connection. The sync bit will be set 1 and the acknowledge will be 0. Next comes the fin bit. So fin bit is used to realize, or what we can say, to close the connection, and it specifies the sender wants to finish the data connection, or it wants to terminate the data connection. So these were all the information we have in this TCP segment with the transport, that is the transmission control protocol. So that's all in the class today.